So we consider a circle having the center C, and we consider another point P with the coordinates x1, comma y1. Now what we do, from this point P, let's draw a tangent to the circle. Let's draw two tangents to the circle. Here, the two tangents are meeting the circle, let's say at point A and at point B. Now, what we want to do here is we want to find out the length of the tangent. To do that, let's begin with the general equation of the circle. Since we are considering the general equation of a circle, we can easily define the coordinates of the center C. So that's going to be defined as negative g, comma negative f. We have the centered at negative g, comma negative f. We can also define the radius of the circle, which will be given by the square root of g squared plus f squared minus c. Now we will do a construction. Because we want to find out the length of the tangent P and PP, we'll drop a perpendicular from C to the point A. It's always going to be perpendicular, that's by definition. Any line joining the center and the point of contact of a tangent, they are going to be perpendicular to each other. Now, we will do one more construction. We'll join the point P and the center of the circle. Now, we get a right angle triangle ACP, which is right angled at angle A. And if we consider the lower triangle, we get a triangle PBC, which will be right angled at angle B. We can consider any of the two right angle triangle. So here, let's go with the upper triangle. So in the right angle triangle, PBCA, which is right angled at C, we can use the Pythagoras theorem. So PC is going to be the hypotenuse. So squaring PC squared will be equals to PA squared plus AC squared. Our goal will be to find out the length of the tangent, which is point P and PA. So PA will be equals to the square root of PC squared minus AC squared. So let's label this as number 1. Now what's PC? So here we have the point P with coordinates x1, comma y1, and we have the center of the circle C with coordinates negative g, comma negative y. So we can easily find out the length PC by using the distance formula. So here PC will be equals to the square root of what we need is the difference of the x coordinate. So we'll take x1 minus negative g, so we're going to get x1 plus g whole squared, added to the difference of the y coordinate, so that's going to be y1 minus negative f, so that means we have y1 plus f whole squared. So this is going to be the length of PC. And then we can also find out the length of CA. Now length of CA is nothing but the radius of the circle. We have already found out CA, so that's equals to the square root of g squared plus f squared minus c. Now what we'll do, we'll substitute PC and CA into equation number 1. So PA will be equals to, I'll leave the algebra for you. So it comes out to be square root of x1 squared plus y1 squared plus 2gx1 plus 2 times f times y1 plus c. So this is going to be the length of the tangent drawn from a point P, external point P, x1, comma y1, to the point of contact A. Similarly, this will be also the length of the tangent PB, because we know for a fact that the length of the two tangents are going to be of equal length. Now, there are two remarks that I would like to make from this particular idea. So remark number 1 will be, so here the PA, which is the length of the tangent from any external point P to the point of contact, if we square that value P, then we're going to get PA squared, which is also PB squared, and PA squared is going to be the power of the point P. This is defined as the power of the point P. And then we have the equation of the circle given by x squared plus y squared plus 2gx plus 2fy plus c. So if we denote s to be equals to x squared plus y squared plus 2gx plus 2fy plus c, it means that this implies that s equals to 0 will be the equation of the circle. This will be the equation of the circle. And if we denote S1 as x1 squared plus y1 squared plus 2gx1 plus 2fy1 plus c, then square root of S1, this is going to be equals to the length of the tangent from an external point P with the coordinates x1 comma y1, and if we square it, then we're going to get S1, that's going to be the power of the point P. So let's try to apply this knowledge by solving few numerical problems. So here we want to find out the length of the tangent drawn from a point 2, 5 to the circle whose equation is given to us. Let us begin. So here we have the equation of the circle given to us. So we have x squared plus y squared minus 2x minus 3y minus 1 equals to 0. We're going to compare this with the general equation of a circle, which is x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. Then we get the value of 2g, that will be equals to negative 2, which means that g comes out to be negative 1. Then we can find out the value of 2f. So 2f will be equals to negative 3, which means the value of f comes out to be negative 3 over 2. And the value of c is going to be negative 1. Now, we have the point P with the coordinates 2, 5. So this is the point that's equivalent to x1, y1, which means that the value of x1 will be equals to 2, the value of y1 will be equals to 5. Let A be the point of contact, which implies that PA, which will be the length of the tangent, that will be given by the square root of x1 squared plus y1 squared plus 2 times gx1 plus 2 times fy1 plus c. Now we will substitute the values. So here we have x1 squared corresponds to 2. We have 2 squared added to y1 squared, y1 is 5, so we have 5 squared. Plus 2 times g is negative 1, so negative 1 times x1, so that's going to be 2. Added to 2 times f value is negative 3 over 2 multiplied to y1, which is 5. And we have the c value, that's negative 1. So this will be equals to the square root of, so 2 squared is 4, 5 squared is 25. Then we have 2 times negative 1, that's negative 2. Negative 2 times positive 2 will be negative 4. So here we can factor out 2 and 2. So we have negative 3 times 5, that's negative 15 minus 1. So let's compute the value. This will be equals to the square root of, so 4 and 4 cancels out. 25 minus 15, that's 10. 10 minus 1, so that's going to be 9, which is going to give us a value 3. So that means the length of the tangent is going to be 3 units. So let's go to the next problem. So determine the length of the tangent drawn from the point 3, negative 4 to the circle. Also determine the power of the point. Let us begin. So here we have a point, let's say the point where here we have the point P with the coordinates 3, negative 4. And then we have the equation of the circle given by 2x squared plus 2y squared minus 7x minus 9y minus 13 equals to 0. Well, here what we'll do, we will get rid of the coefficient of x squared and y squared, which is 2, by dividing each terms by 2. And this is going to give us x squared plus y squared minus 7 over 2 times x minus 9 over 2 times y minus 13 over 2 equals to 0. All we have done here is express the given equation of the circle in its general form. Well, like the previous problem, we could find out the value of g, f, and c. But there's a easier method to quickly find out the length of the tangent. So we will say that the point of contact be A, which means that PA is going to be equals to the square root of, all we have to do is replace the value of x with x1 in this particular equation. So we get x1 squared plus y1 squared minus 7 over 2 x1 minus 9 over 2 y1 minus 13 over 2. And here x1 comma y1 is nothing but the point P from where the tangent was drawn. So we have 3 negative 4 corresponding to x1 comma y1, which means x1 is positive 3 and y1 is negative 4. So let's substitute this value here. we get the square root of, we have 3 squared plus negative 4 squared minus 7 over 2 times x1, so that's 3, minus 9 over 2 multiplied to negative 4 minus 13 over 2. So this is going to give us the value square root of 26, and this is going to be the length of the tangent drawn from the point 3, negative 4 to the given circle. Coming to the next part, we need to determine the power of the point PA. So here, power of the point which is having the coordinate 3, negative 4, that's simply equals to square of the length of the tangent, PA squared. So that means the power of the point is going to be 26. Okay, let's move on to the next problem. Problem number 3. We need to determine the length of the tangent drawn from any point on the circle, so this is the circle, to another circle whose equation is given to us. Let us begin. So here, let's begin by first considering a point on the first circle with coordinates x1, y1. Now, because this point x1, y1 lie on the circle, so it's definitely going to satisfy this equation of the circle. So we're going to replace the value of x with x1 and the value of y with y1 to get x1 squared plus y1 squared plus 2gx1 plus 2fy1 plus c equals to 0. Okay, now our goal will be to find out the length of the tangent drawn from this particular point to the other circle whose equation is x squared plus y squared plus 2gx plus 2fy plus c1 equals to 0. So let's find out that. So we're going to denote the length by s1. So its formula will be, we'll take the square root. All we have to do is replace the value of x with x1 and y with y1 into this equation of the circle. This should give us x1 squared plus y1 squared plus 2 times g times x1 plus 2 times f times y1 plus c1. However, we can replace this value. We can use the first equation. From here, we can say that x1 squared plus y1 squared plus 2gx1 plus 2 times f times y1 will be equals to c. So if we replace this value with c, we are going to get square root of, this is going to be negative c. You're going to get negative c plus c1, which means that the length of the tangent from the point x1, y1 to this circle is going to be square root of c1 minus c, with the condition that x1, y1 lie on the first circle. Okay, so let's move on to the next problem. Problem number 4. So here in this problem, it's given that the length of the tangent drawn from a point with coordinates f, g to the circle x squared plus y squared equals to 6 is going to be twice the length of the tangent drawn from the same point to another circle. So using this information, we need to show that the following equation holds true. Okay, so let us begin. So here we will suppose that we have a point P, let's say having the coordinates f, g. Then we have a circle which is having the equation x squared plus y squared equals to 6. We draw a line from a point P, and let's say it is tangent to the circle at point A. It's also, we have another circle whose equation is given by x squared plus y squared plus 3x plus 3y equals to 0. And the line is also tangent to the circle, let's say at point B. Now there's a condition given here. It's given here that the length of the tangent drawn from point A to point P to point A, that's equals to twice the length of the tangent drawn from point P to point B. Now we use this condition to show that f squared plus g squared plus 4f plus 4g plus 2 equals to 0. Okay, so let us begin. So first we will try to find out the length PA. So length PA will be, all we have to do is take the square root. In this equation of the circle, this can be also expressed as x squared plus y squared minus 6 equals to 0. So in this equation, what we will do, we'll replace the value of x with f and the value of y with g. This is going to give us an equation f squared plus g squared minus 6. We're going to Label this as 1. This is number 2. Let's find out the next length of the tangent PB. So that will be equals to, we'll take the square root. Now in this equation of the circle, we will replace the value of x with f and the value of y with g, which is going to give us f squared plus g squared plus 3 times f plus 3 times g. So this is going to be number 3. Now what we'll do, let's substitute the value of 2 and 3 back in equation number 1. So equation number 1 is going to give us the square root of f squared plus g squared minus 6. So that's going to be equals to, we have 2 times the square root of f squared plus g squared plus 3 times f plus 3 times g. Now let's square both sides to get rid of the square root. We get f squared plus g squared minus 6 equals to 4 times f squared plus g squared plus 3f plus 3g. So this is going to give us now f squared plus g squared minus 6 equals to 4f squared plus 4g squared plus 12f plus 12g. Now 4f squared minus f squared, that's going to give us 3f squared. Then we have 4g squared minus g squared, that's going to be positive 3g squared. We have plus 12f plus 12g, and we'll transpose this negative 6 to get positive 6 equals to 0. Now each of the terms have a factor of 3. So if we factor out 3, we're going to get f squared plus g squared plus 4 times f plus 4 times g plus 2 equals to 0, and we get the required relation. So we have successfully solved the problem. Now let's go to the next problem. Problem number 5. We need to find out the locus of the point where the tangents drawn from the point to two circles are of equal length. Let us begin. So here we will suppose that the point has the coordinates h, k. And we will suppose that from that point P, we have a tangent drawn to the first circle and its length be given by PA. And the length of the tangent drawn from the same point to the second circle, let it be PB. Now it's given here that PA is equals to PB. So let's now find out the length of the tangent PA. All we have to do is take the first equation of the square, replace the value of x with h and the value of y with k. Our length will become the square root of h squared plus k squared minus 4h plus 3k minus 1. This will be equals to the length of the other tangent. All you have to do is replace the value of the x with h and y with k. However, we have to be a little bit careful here. What we'll do here, we are going to rewrite this equation. So let's rewrite this equation. That means we want to get rid of the coefficient of x squared as well as y squared. So this will become x squared plus y squared plus 5 over 3x minus 7 over 3y plus 2/3 equals to 0. Now we're going to replace the value of x with h and the value of y with k. We're going to get h squared plus k squared plus 5 over 3h minus 7 over 3k plus 2/3. Now what we'll do, we'll get rid of the square root from both sides by squaring to get h squared plus k squared minus 4h plus 3k minus 1 equals to h squared plus k squared plus 5 over 3h minus 7 over 3k plus 2 over 3. Now here we can cancel out h squared k squared from both sides. Now we have negative 4h minus 5 over 3h. We have plus 3k plus 7 over 3 times k. We have negative 1 minus 2 over 3 equals to 0. Let's further simplify. Let's do one thing. We will multiply each terms with 3. That's going to give us negative 12h minus 5h plus 9k plus 7k minus 3 minus 2 equals to 0. Negative 12h and negative 5 is going to give us negative 17h. 9k plus 7k, so that's going to be 16k minus 5 equals to 0. So let's multiply throughout with negative 1 to get 17h minus 16k plus 5 equals to 0. We're almost done, and what we'll do, we will revert back to the original. So we are going to replace h value with x and the k value with y to get 17x minus 16y plus 5 equals to 0. And this is the locus of the point P. That's going to be the locus of the point P, with the condition that if we draw a tangent from this point P to the two circles, then the length of the tangents are going to be equal. Okay, so let's do a few more problems. Problem number 6. The length of the tangents drawn from the point 1, 2 to the two circles, whose equations are given to us, are in the ratio 4:3. We need to find out the value of lambda. Let us begin. So here we have the point. So let's call the point as point P with coordinates 1, 2. And we'll consider PA to be the length of the tangent from the point P to this circle, drawn from the point P to the circle x squared plus y squared plus x plus y minus 4 equals to 0. And we will consider PB to be the length of the tangent drawn from the same point P to the other circle, whose equation is 3x squared plus 3y squared minus x minus y minus lambda equals to 0. However, what we'll do, we will get rid of the coefficient 3 from the coefficient of x squared as well as y squared by dividing each terms with 3. So our equation will become x squared plus y squared minus x over 3 minus y over 3 minus lambda over 3 equals to 0. Fine. Now it's given here that the ratio PA to that of PB, that's equals to 4/3, which means that 3 times the length of PA will be equals to 4 times the length of PB. So let's find out the length of PA. So here we have PA, which will be simply the square root of, all we have to do is take the equation of the circle and replace the value of x with 1 and the value of y with 2. So we're going to get 1 squared plus 2 squared plus 1 plus 2 minus 4. This will be equals to 4 times square root of, we have the second equation of the circle. Here also we'll replace x with 1 and the value of y with 2 to get 1 squared plus 2 squared minus 1/3 minus 2/3 minus lambda over 3. Let's further simplify. So 3 times the square root of, so 1 plus 4, that's going to be 5. Then add it to 1, that's 6. 6 plus 2, that's 8. 8 minus 4, that's going to be positive 4. Now that will be equals to 4 times the square root of, so here we have 1 plus 4, so that will be equals to 5. Negative 1/3 and minus 2/3, that's going to be negative 1. So we have 5 minus 1, that's going to be 4. We have 4 minus lambda over 3. Let's square both sides. That's will give us 9 times 4 equals to, squaring 4 will give us 16. Squaring square root of 4 minus lambda over 3 is simply 4 minus lambda over 3. That will be equals to 9 times 4, that's 36. 16 times 4, that's 64 minus 16 lambda over 3. Which will be equals to, we have 16 lambda over 3 equals to 64 minus 36. Now we have 16 lambda over 3, that will be equals to 64 minus 36, so that's going to be 28. So lambda comes out to be 28 times 3 divided by 16. Now we know that 4 times 4 is 16 and 4 times 7 is 28, so 7 times 3 will be 21. We have 21 divided by 4. This is going to be the value of lambda. Okay, so let's go to the final problem. Problem number 7. As given here that if the square of the lengths of the tangents from a point P to the 3 circles are in arithmetic progression, then we need to show that a squared, b squared, c squared are also going to be in arithmetic progression. So let us begin. So here we're going to consider the point P. So let the point P be denoted by P with coordinates x1, y1 such that the PA, PB and PC are the length of the tangents drawn from this point P to the circle, x squared plus y squared equals to a squared, x squared plus y squared equals to b squared, and x squared plus y squared equals to c squared respectively. Now, we can easily define the length of the tangent PA. All we have to do is we rewrite the equation x squared plus y squared equals to a squared as x squared plus y squared minus a squared equals to 0, and we'll replace the value of x with x1 and the value of y with y1 to get the square root of x1 squared plus y1 squared minus a squared. Similarly, the length of PB will be equals to square root of x1 squared plus y1 squared minus b squared, and then PC will be equals to x1 squared plus y1 squared minus c squared. Now, it's given in the problem that if we take the square of this length, that means PA squared, then we take next PB squared followed by PC squared, then this particular sequence will be in arithmetic progression. These are in arithmetic progression. Now, if they are in arithmetic progression, we can easily use the property of arithmetic progression to say that if we take the second term and from it subtract the first term, this difference will be equals to the third term minus the second term. Okay, so here let's replace the value PB squared with x1 squared plus y1 squared minus b squared, and from here we are subtracting PA squared, which is x1 squared plus y1 squared minus a squared. That will be equals to PC squared. So PC squared will be x1 squared plus y1 squared minus c squared, and from it we are subtracting PB squared. So that will be x1 squared plus y1 squared minus b squared. Upon simplification, we're going to get a squared minus b squared will be equals to b squared minus c squared. Or simply put, we have 2b squared equals to a squared plus c squared, and when this condition is met, we can say that this implies that a squared, b squared, c squared are in arithmetic progression as well. So this is how we can use the concept of the length of tangent to solve our problems.